Hello, what's going on? I'm Jun-chan. Welcome back to the stream. We're still doing Comonad things in PureScript. So let's pick up where we left off. So we're trying to find out whether, Comonads are really a type of building block that that could be really useful. Based on a lot of literature that I've looked out there, and the work of Phil Freeman on Comonadic UIs, it does sound like there's a lot of potential, but I'm still working my way around understanding particularly how to compose these things together. But before I get there, I'm also trying to see and deepen my intuition of how Comonadic UIs work, and specifically how we can make the PureScript React Basic, PureScript React Explorer work, maybe draw upon some more regular types of functions, basically. So here's a few things that point towards that. PureScript React Explorer, as it is, uses these types and uses this approach here to basically do the render loop by doing some complex inversion of control and using continuation passing style to have a Comonad full of things that await a handler, and then the handler awaits events. So this sort of double inversion of control is something that allows us to write code like this, which allow to plug into basically DOM triggered events this send function, and send it some payload, which is a monad in the monad we were interested in. And doing that then triggers the advance of the comonadic space into the next focus along the M action, monadic action, which runs in the co-W, meaning the co of the comonad that interests us. And then we, by modifying state, when we receive that callback, that event from the DOM, we are able to basically trigger a re-render of React in the next state that's going to be waiting on the next handler, that's going to be waiting on the next monadic action, that's going to trigger the modify state. So that's the situation, but I find this, well, it's appropriate, of course, to be able to write something like that, where you basically, in some sense, I suppose, couple the UI events to the code that's going to launch these events. But in order to achieve that properly with this approach, you have this double inversion of control. And I think I'm being drawn toward more of an FRP sort of paradigm, where I can, hook up my handlers within the UI, because even though it's coupled here, it's still the right place to specify where you want to hook up an event, right? On that on click of that particular button. But maybe here we can sort of hook something a little bit more generic, maybe that's going to just give a name, for instance, to or a type to the particular type of event that we are throwing here, and that we're triggering. And then maybe in some other place have a neat way to look at events as sort of entering a component graph and then exiting a component graph. So a little bit like what we find in FRP, exactly like what we find in FRP. So that's an intuition I've been sort of toying with for a while. Actually, I didn't turn on that light. Bing. I've been playing with it for a bit, and I think, I haven't narrowed my focus on it specifically, and maybe at some point that's something I should do. So let me do a little bit of housekeeping with my log here, as always, and move this to today, and looking at Chronofold and PureScript and so on, I think, I mean, this is kind of what I'm saying here is Comonadic components plus with FRP style input output. And I could focus on this problem and try to find more about it. At some point, it might be beneficial to do that. And I see that I have a battery message, which usually is my keyboard rather than the mouse, contrary to what's being said here. So yeah, so that's what I wanted to capture here. I still have halogen on my kind of to-do list of things I should most definitely look at while I'm actually, you know, sort of trying to smuggle some UI framework design right there, which is a little bit over my pay grade, to be completely honest, but that's how you learn, or that's how I learn, actually. Maybe that's how you learn too. Okay, so that's sort of the broader context, and specifically last time we wrote this bunch of to-dos where we were actually experimenting in another repo that's sort of is not encumbered with all of the UI machinery, but more specifically to try and play with some code-free constructions and see how that works in terms of where in particular we're going to be doing side effects in our Comonadic interpretation. And that's sort of been a thread that I've been also following in the past 2, 3, maybe more than that, 4 or 5 streams. And I've tried a few things. I've tried to go with Phil Freeman's recommendation, which was around his blog post with co-effects. I've also looked at co-effects in the Thomas Petricek style, which is different from how Phil Freeman proposes co-effects. But I'm trying to do it more in relation right now to what Phil was trying to do, which is be able to use some kind of base monad, such as IO or effect in our case, which is how do we smuggle an M somewhere inside our constructions. And I suppose that's effect in the Comonad stack here. And maybe we can look at it as one of, you know, M in the W, sort of such as co-free compose MF A. So here we have a Comonad co-free F, which somehow has an interleaved M, and that's in the style of Phil Freeman. We have M in the M, which is in free, we can have compose, well, MF again, we could say, and or maybe GF, or no, I suppose compose MF. And in that case, that's more like actually that's co-T and co-effects, whereas the free with an M inside, that's more like what we have in the actual PureScript React Explorer, I believe. Let's check here. The fact that we have a handler that can return in effect unit means that, in fact, in that handler, meaning here in the send, and in fact even here outside the send, we could do it's not outside the send, actually, it's inside the send. Here we could do any effect we want. We could also, and I think that's more like the co-T. When I used the Coty approach, it was an M in a W, but also more specifically in the Coty W, which means in the, well, it could be in both actually, which was sort of a little bit weird, but we played with that for a bit, and having the possibility to write, actually I think I made the mistake of basically sort of removing some of that code when I was refactoring, and I do have it here. No, I do have it here. Inc in Coty effect counter interface effect unit is able to have a log effect, and then here in our, well, here it's in our counter interpreter that we also were able to have a log effect. But it's underneath compose. So in fact, it is in the, that is in the comonad. That is in the kind of that is more in the monad here, because we're in the co-W, which has some composing, but we return in effect units. Whereas here we are in the comonad. So that's here, either in the comonad or in the Coty W, which is the monad here. And we're able to put effects in both places, which is maybe too much power, I think, because I don't like the idea of having the possibility to do it in both places. I think it should be only in one place. And then I think I was kind of doing a wild goose chase, which was trying to put it in the interpreter, M in the interpreter, in the, it's not fair to say the interpreter, and I'll explain that more, but in the explore. So a little bit like basically in explore M. But I think because of what we were figuring out last time is because of the universal quantification of the explore function here. No, not this, pairing. So hold on, this is not, I thought I figured out that in the end it wasn't pairing that. Oh no, right, it is pairing, and let's see, where is Explorer M? That I deleted. Okay, so let's find Explorer M again, and let's try and recapture some of that thinking. FRP here, Explorer M. Explore M, let's get the source code. There we go. That's the guy. So when we do the explore rather than the explore M, then it seems like this universal quantification of x and y, basically this rank 2 type here, where x and y, where the function we pass needs to work for any x and y. It cannot introspect the x and y. In order to get something like that, we have to write something super generic, which in fact is basically pairing. Is our pairing instance. So in our class-based version, pair is able to pair, I think, which one do we use, for instance, in our example? We use, yeah, we try to pair tuple and function, I believe, but it's not really visible here. Yeah, my F and my C. that also doesn't sound quite, oh no, it does, right, because my F is free of tuple R, my C is co-free of function R, and so that means that the pairing instance we use is the one that pairs a tuple of a given thing and anything and a function from that same given thing, and that is that pairing tuple function instance, or the symmetric one, which we've sort of added here. That pairing GF implies pairing FG with this instance chain thing here that I'm not too happy about. But anyway, we have, so what I was saying is that this pairing is has this existential quantification. So it basically works for things that that don't look into the B or work for any B, any A, any B, and any return, any F which given an A and B gives back a C. And yeah, the way this is written is slightly different because there's either zap or pair. There's like kind of these two different style, kind of a slightly more, I would think, more applicative style here, and this more kind of slightly more symmetric style here. So the question that started forming in my mind, given that we know that we basically, when we are constrained by an existential type like that, it means that usually there's only one good result, or like a very few good results. So that's something that is a fairly common pattern in Haskell or PureScript. And so I'm now curious about, for explore M, the fact that we return my here. What does it mean? Does it mean all of a sudden we have access to many more explore M's, many more rank 2 type function that we pass here? Or does it just mean that we use pure? Because if it needs to work with any M, but it's not for any M, right? It's like it works for a given M here. So it feels like for a given M, which would be effect in our case, then we just still use pure here. So in fact, does explore M depend on explorer? It doesn't. It doesn't. And where does the M show up? Ah, it uses state T instead of state. Right, because it's still like this thing is still one step inside a whole nested free monadic value potentially being eliminated by a whole nested co-free value, comonadic value in co-free. So it makes sense that it decorates the sort of the inside of that state propagating function, because the way in which, by having a whole free value, the way that we need to apply this repeatedly for each of the layers of our free and keep state. And now, since each of these steps is going to return in M, we need to build a state T monad transformer. And And I'm kind of expecting to see a pure somewhere there, but I'm not. Hey, what's up? Chitozu, Chitozu go kari. Chizoku go Chitozu go kari. Hey, what's up? I hope I said that right. I tried to say it with a kind of Japanese accent, but I'm not good enough in Japanese to know whether it is, but it quite looks like this. How's it going? How's your day? A good moment to drink a bit of water. Yes. Good. I'm pretty good. I'm still liking my exploration in PureScript, and feel like I'm learning quite a bit with this different thread that I'm trying to unravel. Are you familiar with PureScript, which is the programming language I'm using here? Right. Yeah, right. So that's one of these things here that I was looking at. So either our monad is in, we use the Coty coeffect approach, which leads to either that or that. All right. Have a good day. It was good for you to stop by. Good of you to stop by. So we could have M in the M3 compose. Bye-bye. We could have M in the M, which means which kind of means basically kind of monad stack transformers. I was thinking we could have it in Explore M, but not really, because we are too constrained by the universal quantification. So, and I think I was on this bit of a wild goose chase about this for a while. I thought I could use Explore M, and I was seeing an illusion here. I was thinking that there could be some interpretative logic here, but in fact, all is kind of converging better, because I just realized that I simply forgot that really Cofree, that the traditional model of using free monads is that you don't use Cofree comonad to pair them with. You just build an interpreter for free, or several interpreters for free, and that in fact passing it a Cofree comonad is the equivalent of building an interpreter or several interpreters. So actually that's better, because there's no room to put it there. If we do I believe that if we do the kind of coeffect thing, then we could put it in both, but I don't like that so much. Putting in it both is kind of unfair, I suppose. It's not exactly true. No, it is true. Like, the ink really is a monadic value, and we can put a M in there, and when we put the M in here, then we are using it as a more of a common, like as in its comonadic form here, because that's really is the interpreter. So I'm actually not sure how I can, and by the way, okay, this is a bit of too much of a tangent, but I think that this passing the count here is basically a hidden store comonad, I think, that probably we can factor into our counter interface somehow, maybe. I'm not 100% sure about that. Yeah, no, I think that might be the case. And that is actually pretty neat if we're able to do that. So let me write it down. I think I want to extract the model, the counter model state into Comonad, maybe. So this, we know it's nope for the same reason, because we're too constrained by the universal quantification, because I didn't write that it was for AB. Even though it's not for M, we still need to just put pure here. And so what is where does this leave us? In our playground here, if we say that we have, well, first of all, in our playground, we probably can let go of this, because if we redo something similar in order to have a simpler example than the one with PureScript React Basic, then we still need to bring in like comonads. But I think maybe I can figure this out here. One question. Well, first of all, maybe we need to try and get back to where we were at. What I was trying to do was, the reason why I moved to the playground is because I was sort of in the middle of a refactoring here, and I wasn't sure whether I needed to complete it or whether I needed to backtrack. And so that leaves things a little bit hanging here. And maybe it makes sense to have something just a tiny bit simpler in our playground so that we can understand it a little bit better. So does this even fire? I think it does. Yeah. Okay. So let's add to it. Explore M is not the way forward. Let's instead go back to co-free F. And how we can interleave effects in the interpreter, which is really the co-free interpreter, right? So let's try and do a tiny version of that. So in this case, we could do the counter, to be honest. That's going to be a simpler way to do this. So we take a counter, we take change and ink, and maybe the counter interpreter, and let's take the whole thing, and let's remove the sort of the rendering things. At this point, yeah, I know I don't want that, but let's leave it just to be able to see it. But I'm likely to want this interpreter though with effects in there. But I don't like where it's at here. I want it to be somewhere. I want to be able to smuggle it inside some of this function in counter interface. So that's what we're going to try and do, I think. But then I need to find out, and for that I need to get my types to line up a bit. Basically, I want to pass counter interpreter here. And instead of rendering, since we have a component counter, what could we do here? That's quite an interesting question, actually. Because here, we don't really want to render. But we do want a function that returns, but maybe now we have an opportunity to try and return into different things. Although I think when I try to think about whether we could simplify UI, I quickly realized that it was not really possible to make this how I wanted. So I think maybe though we can use this type. And in that case, we'll just make this into render, and we'll return into, let's say, effect string, such that, so all of this has the a form because of unfold co-free that allows us to use build, not they use explore. But we do want to change the Explorer we want to use. Maybe not with Explorer M though. Maybe more in that shape, right? I mean, not exactly that shape. This would be what. Yeah, we don't want to return to effect React element anymore. I think I'm going to need to backtrack here from what I've tried. Wow, this is. Yeah, I think this was a wild goose chase. This I think can remove. We can remove that. Same here. And here we're getting closer to the refactoring we had, and I think it was pure extract state handler, I think. That seems okay, I think. Yeah, we're taking state, which is the component, which calling it state is a bit wrong, right? For multiple reasons, but let's leave it like that for now. And we just had where, and I think our handler would have been this. And I think we are not, oh no, we are returning in effect unit, and that should maybe compile. Oh, yeah, not happy with that. W is undefined. Right. In this case, it's go3g. And we don't have pure. And that compiles again. and here it doesn't. Because our list is borked. Because our sum is borked. Because we've changed the type of component, and that maybe we can revert on that, because it was making me a little bit uneasy because we're losing some of generality of what we had, and I don't think that's necessary. We just need a comonad now, and we need to call it back W. Affect unit with unit, because and here W comonad, we're basically reverting our changes, and we compile again, and that should mean that now sum should be back to its original self and compile, and it does. And then lift, this should just be lift off, and it should just work again, because there's no such thing as component W anymore. It should work just like this, and yeah, it does. We just need to remove that. Boom. Okay, and therefore we don't have component W here anymore. And that gets us in a place where I think we can compile again. List, counters component, and Explorer. Build co-free. Why isn't that working? Co-free list interface. Yeah, of course. Now it's co-free list interface. Yes. Okay, good. And then here it's component counter. Yeah, I was trying to simplify that, but that might have been just a mistake. Right. Yeah, so I think we could say counter is now co-free counter interface, and we're back to calling this counter interface. I think that's probably the right way around. I think so. Okay, and here, and here. And go counter. Da-da-da. Yes. Hold on, I said counter was co-free counter interface. Do I need to lift that somehow? No. Shouldn't need to do that. Component counter. Here. Is that right? No. Should be though, but counter is called free counter interface. Should probably be. Oh yeah, no, it is counter interface up there. I'm pretty sure. Yeah, of course. Which I think is not as pretty as I'd like. Maybe having counter here would be better, but let's just stay with it for a bit. And yeah, handler is not the one we want yet, so we can do this. And counter interface with tag go free counter interface. Yeah, I suppose it's because we just want counter here, or maybe we just want counter interface. Just want counter. It's a little bit okay. Well, now this is supposed to build. That's this one. Actually, I'm going to npm start. And it's supposed to be built. I reload. Okay. Okay, if I change a thing, it works. So, okay, so we're back where we started. So let's now copy this back into our other attempt. Right. Which includes ink and change. And then here are, yeah, right. Counter is this. We deleted the other eval. We want to keep that one with the log. And I'm starting to see something here. Yeah, no, I'm not sure. I thought, could we have effects there that are called in? I think I was thinking that maybe we could use the regular trick of having a free monad DSL, and that we use that here, but it doesn't make sense. This is our interpreter, and I mean, there might be cases where we do want to have a free DSL language that we can use in our actions. Actually, that might be useful. But at this point, I'm more interested in the grounding of some base comonads that will need to do things like calling the database. And even if we do what I was saying earlier, which is to have free monadic language up there, then it will need to still be interpreted into a base monad effect, in effect, into our interpreter. So we still need to figure that out. It could be, though, that we might be able to decouple things. Yeah, I'm not sure yet, but it's going to be easier if we have a simpler example like this one. Okay, render should probably just be right. So UI, so this is counter interface here, and this is counter. Yep. And then clearly we're not, if we render into fx string, then this will need to be something like counter show count, and then we, interestingly enough, we're back to a similar problem that we try to solve using Purview, SDOM, PureScript SDOM, trying to hook up and we try to hook that up into React Explorer too, trying to hook up a subscription to a timer in there somewhere, which is one of the ways in which you can be called by something external, right? Without using something like readline in Node.js. Okay, so we don't have where anymore here. And then we need to import a bunch of stuff. In fact, we need to import so much. All the core stuff is going to be there. So it's mostly the components, so it's not too bad. Yeah, we do need to import code.trans here. That will be not in function pairing. Yeah, it is in function pairing. Paste. Okay, so that compiles. Now, presumably that does too. We just need to import, well, we don't need that, to be honest, right now. Neither do we need that, or nor do we need any of that. So that's because this is going to now be in fx string, and we don't really need anything else, I don't think. We do need Coty, and that's going to be, well, yeah, I think that's going to be given by the library. And finally, so maybe here we just say that actually we have what we want, so we just use this. And right. Okay, hold on one second. String with render takes a handle. Oh, right, yes. It's that. Okay, string with fx string, that I can deal with by doing pure. And then And then indeed we do have a problem with the shape of counter interpreter, but for now we can just call counter interpreter pure and figure things out from there. Without the compose. But maybe with the type declare. Yes, okay. Something else. A bit of syntax and then pure here. And that compiles. So now we can then log. Well, so now at the top level, normally we'll call Explore, which we now call React Explorer. But in our case, let's copy these two guys and find out what we're going to do. That's sort of like string Explorer right now. And here that goes to effect string. And right here we also go to effect string. So maybe we don't need this guy. What we need is an explore write, which is really going to be interesting, because that's pretty much exactly where our input effects are. Basically, either our externally triggered sensors or an event loop. So that's where we could write a recursive call to explore here, I'm pretty sure. So let's see if we can pull that off and see. It could be that actually that's going to be in log as well. So we would explore. Here we have some notion of passing state, but really in our case we pass the initial value of our counter, right? And then write is something that, given a component, returns an effect unit. And well, I think we're kind of saying that that's what loop is, except that we want to advance. And so that's where the fact that we should be able to have a handler here and call the handler once in a while does the inversion of control. So how are we going to handle that? I'm going to remove the stuff we don't need. And I'm going to take a little break and get some water and other things. Be right back. Okay, so let's carry on. I think here we want to do, and we want to return, there will be some kind of result string which we want to log. And how is that gonna loop? It might not loop how we want. Maybe we want to log like so. Not sure whether that will loop how we want either. And then here we need to decide what is going to be the tick. And I think is where we might reach for our delay. Or some kind of subscription, something, basically a JS timer, right? And we tried to do this, I think it was in main here, with our input. Yeah, we tried to do it in a few different ways. We did have delay somewhere at some point, not log, delay. And then we try to also do something even more funky with subscriptions. But here I think I'm rooting for that. Let's see if what we find in the library for delay. It's F. It's in F. Well, maybe we can be in F here. Maybe that is a good place to be. We need to import it, but effect.f. And actually it's here. That's cool. And so we, what's that? Oh yeah, okay. Right. So am I using this elsewhere? Explore prime, explore m, and explore, and I am using it here. So let's just say prime and prime prime. And call this guy prime. And this guy prime prime. And then okay, so yeah, I suppose there's a question of what do we do with loop here. We could say just loop. I'm not sure. What do we say? Pure loop? Maybe loop is not okay at this point. What's going on? Well, so we're going to need to put f sort of everywhere here, which is fine. But before we do that, let's try and fix it for f and see whether we can even make this work, even if it's maybe going to blow up the stack or yeah, loop should take an S. And as it loops again, the expectations with React was that the handler would be called, which I suppose we could just do here, maybe, right? We could just call the handler here, couldn't we? Could just say handle this. And we want to delay that, but until we do, hey, that compiles. And that is shadow, that's true. Okay, and so my expectation is that will either blow up the stack or it will display a counter incrementing very fast in the console. Yeah, so it blows up the stack. Okay, and I think if we defer, I think if we actually put this in a thunk, wouldn't that work? But then we need to execute it. How would that work? I think for educational purposes, I should try to find a way to at least make this not blow up the stack. It is so explore, I mean counter is kind of infinite. When we do unfold co-free, I suppose maybe it's the handle that should be deferred. The co-free has a lazy in it. When we unfold co-free, I think we defer things. What if I don't handle? Then we never call, we never move forward, which makes sense. Yeah, so that's interesting because we do have a simpler version of the same problem we were tackling before, which is how do we register an event subscription, especially like more generically, because here like we could have like a DOM callback, but what if we want to register an event while we initialize our application, but then how do we pass it the handler? And then this whole inversion of control and the fact that the CPS style inside the base type, the carrier type of the Comonad makes it hard for us to register a callback, which is why we use this input har, where we were also passing to explore some kind of input, which made us, which was really, not pretty. So that's good that we can back at this, but with a simpler view and having learned more. But what are we gonna do here? First thing is that I'd like to be able to call handle. Okay, I'm going to. So the other thing that I tried to do the other time was to remove the CPS style from the component Comonad, and which means that we're sort of then passing monadic actions from somewhere else. I'm now wondering about the stateful nature of things, meaning can we, I mean, I think we can we make a co-free action that will be that will allow us to get the current count? Which is really again about this, whether we can be in the store comonad and therefore just make access to state part of the base functor capabilities. Actually, not the base functor. We can just actually use the store comonad and compose it with the co-free comonad as well, in a co-free in a comonadic transformer, comonad transformer stack, or a deconvolution, which is something we don't know yet. But okay, I'm being distracted again by the store in these guys. If we pass handle here, if there's something we can do at this level which would allow us to call handle. It does feel like it's about composing comonads, co-free comonads. S2A. So what if run was let's write UI again. Oh, we have it up there. Actually, it's good to have the whole thing. So here we want counter model. Actually, we know what we want, don't we? Well, yeah, we still need to write it. To UI. And so let's unpack that. To handler co counter unit, which is co counter unit to effect unit to effect a string. Yeah, that compiles. Takes a C. Ah, yeah, the handler. So we could have the handler here if we wanted. And then that kind of maybe does what we want. I mean, that will do it at every step. But we kind of want to just wrap the component with only one layer. Is that what we want? Let's look at the co-free. From a label and a functor full of subtrees. A functor full of subtrees, but does this mean just a counter interface of this? So one sec. Are we saying something like this is run? It's a component counter, but we're going to init it. And init will be something that will return a component counter from an existing component counter and some stuff. well, so since we know this is a co-free counter interface, blah, what we're saying here is that maybe we have a counter interface of a component counter, and that's being given one of these things. Such that we can do init setup, run, and basically init being mkco-free and setup being something that will run only once, which right now, let's say, is going to ignore its input and which is a function, but let's say we don't. Okay, fine. Handle, I think, is really what we're looking at here. And then we'll handle well, to be honest, we could increment, but that's not what we want to do. We want to subscribe here. We want to subscribe having access to a handle, and we do, and that's good because I think it means we can do like some of the things we were trying to do before, like delay and whatnot. I think, although we're going to need to go into AF, but maybe it's fine. We do this. Yeah, right. So if I put the delay here, then it's fine. But then it's not the same thing as registering with an external clock. And so now I'm mixing the two approaches. And what I want to do indeed is register with an external clock. So let's go back to FRP event time and see whether we could use, for instance, interval. So if we say interval, did you hear that fly, by the way? Interval 1000 that creates an event. And events, yeah, I forget. Tuples, events, they're here, if anywhere. And the dog tells us not much. Subscribe. I provided a callback. Yes. So we do subscribe to an event, which is this interval 1000. Provided a callback, which is do taking that event, but we ignore it. It's time. We could use that possibly, but in our case we'll just handle, which will hopefully move things forward. And we do need to wrap free impure unit here, and then we need to import frp.event.time. frp.event and frp.event.time. And we need to import these guys. By first of all adding them. Yeah, I think that we need to do a little bit of yeah, at least for event. And then for behaviors, I believe we need that too. Behaviors should be in the package set, and I think has an S. And that's not the right place. And oh no, it is the right place. And yeah, how are things now? Yeah, we still need to put event here. Okay, so problem is not the one I thought. It's line 230 and effect unit with string. Yeah, because this whole handle, hold on. We want effect string returned by setup. So we should probably do pure and an empty string. And then run. We would like to have type co-free counter interface. Yeah. What's the problem with that? Hold on. Oh, init is mkco free. Ah, okay. So it takes setup, and then we need to pass it a run that is being wrapped by inside a counter interface, which is weird. But I think basically it's going to be, I mean, is there like an identity counter interface? Is that what we want? We want to use this as the wrapping functor. So we need to provide it with a change count. We need to take any int and return what we want, and take increment and return what we want. So that does point to some kind of identity wrapper or whatever, for however that would be called. Maybe how would that be called? That would be, I mean, it could be called, no, make counter. Which would take a, it would take a counter and it would return a counter interface of a counter. Of a W counter, really. So it's not the same thing. Oh, hold on. Does it take a component counter? I think it takes a component counter. Yeah, that's easier. And maybe this could be A, to be honest. I think this would work for all. So this is a coalgebra, maybe something like that. And it's just, no, we ignore the int and the A, and we just give back the A. How's that? Maybe it's this, and we need unit. Why do we need unit? Or empty row. Change count, not counter. And then we pass mk counter to this. And we get a little bit closer, and we're waiting for effect unit here. So this should just work, right? We could even maybe do this, no? Do we need to also do this? So yeah, I suppose you do want to say something like this, or what's wrong with that? Ah, yeah, okay, we can discard our unit. And we compile. Okay. I am holding my breath. Hey, so Excellent. So it does do a subscription, but then I suppose Inc doesn't do what we expect, and it should add 1 to the count because we're using counter interpreter pure as our run function, but it doesn't happen. Now, what if we also add this in here? Now we have two handles that are sort of competing. I'm not sure. I think that would still blow up. Yeah, still blows up. But there was a sense that this somehow was running in the right sort of stateful context, but here that we're not anymore. The word coroutine just floated in my head because I had a vision of oh, it would be nice if we could just take only like the first 5 of this stream and then realize that this is part of the vocabulary of pure script run streaming, and that pure script run streaming in some sense that does deal with producers and consumers. In fact, in the co-effect blog post, Phil does talk about exactly that right here, producers and consumers. But we're not exactly here yet, but this is a bit conspicuous. Okay, so let's try and first understand what's happening with our current code if we don't use the handler there. So I think basically what ends up happening is that we set up our subscription, but we set it up with a handle that stays the same. Whereas what we want is have a handle that is actually passed all the way down, which is, I think, what I was trying to do by, in fact, passing an input all the way into Explore, so that in Explore we could run input. Let's think about it from another angle. If I imagine that this is more like an FRP arrow network that I subscribe to a timer, then when I send my payload, basically what I'm expecting is that as part of the arrow network, I have access to state. And so the fact that state is threaded here and dealt with basically by unfold cofree here, that might be one of the things that is limiting us here. That if instead we refactor the store comonad and the co-store monad, aka state monad, into this, then maybe we could use state in Inc or in the interpreter. So let's try that. Of course, the weird thing is that our counter model kind of means state. And so therefore change count, in fact, is part of the store replace kind of thing. So let's go check out the store comonad. And we have pick and pass, and but what we really want is the pairing that we got from this side of the world, isn't it? This thing right there. We have monad state on CoTWM. And monad state gives us what we want, which is get, put, and modify. And so my change count really is put. Okay, so let's refactor it that way. So first of all, we do have these guys. So what I'm saying is that we are not going to have change count anymore. We're just going to have a decrement, for instance. And then we are going to do what? We're going to compose, we're going to create a comonad stack transformer. And to do that, we can, maybe we need to do it with cofree-t. That would mean having to rewrite a whole bunch of instances, but we might need to do that. Or I say that cofree counter interface is our base comonad, and then I just use store. So I say counter is store of cofree counter interface unit. SA. And we create a decrement. But we try to be in co-off. Co-off counter, really. Maybe not here. I think here we need to lift stuff. If we want to be in co-counter unit, then we need to lift things. Yeah, it's about the wrap free as well, like this whole wrap free thing. Which arguably we just want to wrap inside those. such that we do something like that. Which leads to having a co-counter unit here. As long as we can lift things which would be in control Comonad trans class lower. So if we lower that, okay, yes, okay, so maybe unit here, that's not great, but I suppose so. And then counter, oh, right, okay. Okay, like so. And MK counter now is decrement. And that's type A. So I think wrap A actually will work here. And a type class instance for who? Okay, we might need to annotate here. Right. Oof. Yeah, it's tricky because this is already a monadic value. So if we lower anything, then it should be around there. Or because Kuti takes a Comonad full of A to MR. That returns an MR. Do we have Comonad transformer examples here? No. And tests. They're in examples. So how do we do this? That won't work. Critique is to W. one of these guys. Oh, hold on. Counter unit. Okay, I think I have this detailed somewhere in comments. How the wrap functions. Wrap. Maybe I have this in Comonadic Explorer. I do not. Add folder to workspace. I might have it in updated. No, that's really just updated. Maybe I have it here. That's possible. Yeah, so I have send as, so that's the Arthur Xavier formulation though, so that's more complicated. But I think in his, actually, that's maybe useful to look at. I think in his, he actually doesn't use wrap free. What does he use? He just sends write and write or increment. And that's the counter action, which is the a free of counter event, so it's not in the base functor. And he uses lift F. And lift F is just to control monad free or lift F. Interesting. And maybe we can use that. Lift F. Takes an F to a free F, and in our case, yeah, it's not immediately available, so maybe it doesn't play well with Coty, but yeah, because you got to remember that in Arthur Xavier's thing, he actually doesn't use Co. Okay, let's just ask what should be here. This doesn't work really well. We don't need to have that for now. And if we say wrap free, then you're unhappy. Let's just double check that this is not some shenanigans because of precedence. I want to check it something in this guy. Yeah, it's just unit here. Okay, so you're saying this is not so. This is not so bad. You're just saying that. Is it because of the type of pure unit over there? No, it's not. It's because of the type of wrap free. So, I mean, it's true that it's okay. Let's just double check that we can make it work if it's co-free of just counter interface. So even that is not good for us. Though I would think that it would be. But okay, let's take it a step at a time. I think what we had before was this, and this should type check. And so should this. And this. And now, of course, then we need to lift things or lower things. So what is it that we want to lower? Maybe that's where we want to lower. Oh, but hold on 1 second. Without co-free T, I can't. Can I lower? That's an important question. Co-free Comonadic transformer functor F, and this has the trans, right? Yeah, it has the monad trans. Maybe I need to start with constructing a store Comonadic transformer first. interestingly enough, this stuff then S2A. It's almost, we're not too far. Hold on 1 second. And for CoFree, as this type. And now I'm saying we have an S2A and an S. It's just the S2FS that's going to allow us to construct our CoFree FA, but is store-t exported? Okay, just do store-t tuple. W is the we have a W of S2A. Okay, I wasn't expecting that. Because that means we need to have counter interfaces of S2A, which is possible, but it changes things. But it makes total sense actually, because we need to be able to access the state. So, and that is actually S2A, exactly the MK counter right there. Okay. No, it's not S2A. It's not true. But these are the counter interpreters are. So the counter interpreter is actually, I think, the base monad, the tuple of counter interpreter. In the W monad. Yeah, so that's not still not right. We're saying, okay, let's try and write one down based on this time. I'm not sure whether even that's exported, but let's try. So in our case, the W is CoFree counter interface. Just double check that. Store of CoFree counter interface. Of counter model to A unit. No, state is counter model, and so A. So that's quite a bit different, but I think that's what we need actually. Actually, we need to make it store-t, I think. And then no, hold on. Yeah, that's what it means, but we can write it as SWA, meaning SW A. Which is not what we had before. And now I'm saying maybe I can build one by passing it some builder and some initial state. And then builder would be of type co-free counter interface counter model to, in our case, I think effect string in our case, isn't it? No, not exactly, because we had some really weird things inside our base value. Oh yeah, that's probably not going to work, but unless we say, yeah, that's the A, and the A is crazy, but that's just the way it is, and then counter model. So the crazy A would be this. And then builder would okay, yeah, I suppose that's when we would wrap our things inside the base monad, but we need to put inside it an A that is counter model to blah. And so that's quite like what we have, really. Isn't that just going to work? Store T, the constructors, please. Store store T and the stuff inside. Where's that? Yeah, that's MKCO free. Oh, I thought we had that for a while, but what's going on with that? Oh. Oh, right, yes, okay. So we need to do another one of those, I suppose. Yeah, damn. Okay, maybe we get rid of the init setup because it could be that we don't need it in this new world because we'll have access to the count. So in that case, it's just run. And we have a kind issue here. Yeah, I think because this counter model, that's just a tuple thing. We don't need it. And counter interpreter pure. Oh, hold on. Maybe we don't need count 0 anymore. Builder should be that co-free thing, and unfold co-free should give us a co-free, but it also needs a startup S. So init equals count 0, and we'll pass it to builder as well. No, that doesn't seem right. Doesn't seem right. Maybe because we kind of want to create a co-free F S2A. So unfold co-free, we're not going to need that anymore here because we are dealing with that elsewhere. So I suppose that's where in theory we could lift and lower, but no, I'm not sure that this is going to work here. I mean, let's try this, continue this way first. It's getting quite late as well. So we're trying to add a contravariant argument to our already pretty crazy CPS style carrier type. So if we pass it, so is the component counter type, is that going to be what we want? Well, I suppose it is, as long as we properly pass something of the right type in there. But it's pretty close, but what's missing? What's missing is that it's not that render is a function of S2A, and we don't need to we don't want to unfold co-free here. We probably want to make co-free. Not in any way that looks like this. From a label and a function full of subtrays. You know what? Maybe it is actually. So mk co-free from an A and an F co-free A which could be just a mk counter of this weird thing. So it will be an mk counter of a function from counter model to mk counter of a function from S to render S. Except that that's not enough for us because we need an interpreter and oh, right, hold on. Maybe the shape of this now is different because we're going to have the count passed in there. Yes. Okay, so hold on now. Maybe this is working out like we want, which is that. So I'm not sure where render is going to show up at this point, but let's take a quick look at how Arthur Xavier does it. Main increment build go free. But that's, yeah, that's recursive, whereas here we want to build it just one step forward. Hold on, I had it. I think I had close to it. Instead of make counter, we're doing counter interpreter, but now counter interpreter is of type counter interface. That might not work for us, but counter model to well, to be honest, to component counter, I think, or at least UI, maybe that UI thing. And that would mean something like right. So we wouldn't be rendering, we wouldn't be passing that, right? We need maybe to pass like a render function here. And say render of count sub one count, and then count and render of that, and then we'd say counter interpreter render, and what would be our base value? Probably something like it. It needs to be the initial rendering. Hold on. I think it can be this, maybe. Okay, what's broken now? Int with count int. Int with count int. Yep. Type checking. Function with cofree. I need something wrapped in one layer of F, which counter interface is one layer of F. It takes a counter model and return a UI co-counter unit. That does seem right. What's going on there? That seems like that's the wrong counter interpreter though that I'm using. So hold on 1 second. Counter interpreter. Okay, let's Spago build. Count it with type cofree counter interface. So I take this render function that returns this, and that sounds fine to me, right? And then I make a counter interface with takes a counter model. Oh, right. Okay, so hold on, is that really what we want then? Counter interface. It's not, no, it is. So this really is UI co-counter unit, right? In that way. Okay. Okay. Cofree FA. This is just that I'm returning the wrong thing here. Doesn't really seem to be the problem. What am I doing here? Counter interface. function with type cofree. I do not get it. Something I'm not seeing here. Render is this. We pass render. Maybe we should call it F. That's not nice. Say RDR. So you're happy with this type? So you know what? I still don't know how to read these things. Could not match type blah with blah. Does not tell me which one is expected and which one I had, and that's always throwing me off. Oh, right. Builder. Hold on. Builder needs to be a W of S2A, meaning a cofree counter interface of S2A. Cofree counter interface of S2A. I think this is the right type. Let's check. Okay, just one string. No. Yeah, so you want this, I think. Right, we do have the handler somewhere. Is that what is meant? Or maybe even... Yes, but that doesn't solve our problem. So can the type checker help us here? Looks like maybe it can. But we'll need better indentation than this. There we go. Let me be right back. Just gonna Okay, so just a tiny bit more. Maybe we can figure it out. Okay. I think I see. So my what? Oh yeah, of course. It needs to be a counter interface of co-free counter interface of counter model blah. Am I right? Such that if I do that, then the type error should be here now. Yes. Okay, so so now when we pass render to counter interpreter, we're really trying to build here a co-free counter interface of all that, which is where we're trying to do in the first place with mk co-free. So we use mk counter to create the basic one. And now yeah, no, we're still not good because we have a counter interface, but we're not wrapping the right thing, which is a bit annoying. But here basically we want to be in co-free. Yeah, we want to be counter interface of co-free, counter interface of all that stuff. And so now types align at the bottom, but we move our complexity up here. And we're saying here that we create a counter interface, but inside of it, we put a co-free. So do we do this like so? No. We'll have the same problem if we try to do this. Maybe we do differ. Maybe we do that trick where we did this earlier, where we pass some kind of id. That's just going to recursively feels a bit strange, but maybe that's okay. Maybe it's saying that that particular structure doesn't change. Then when we compose it with the state, the co-state comonad, then the state is going to be the thing that sort of makes it change. No, I can't buy that. So let's see whether we can reproduce this. And in that case, then yeah, then we are actually creating a value directly from it. Is that what we're saying? My C being this. I mean, in that case, I think then maybe I don't even need to build that. I don't need to do MK co-free. Yeah, I think that might be right. So let's defer co-free instead. Of a tuple of a oh my god, this is really involved. But that's it. Yeah, that is it. I'm not sure that it's simpler by any stretch of the imagination, but that seems right. Oh no, not anymore. Yeah, right. So are we trying to say that this is kind of id and then it is this monster? It's a FCO3 face, so it's what was before. So this it sounds like not as straightforward maybe as building it with this, but this is actually MKCO3 that I was using right there. Okay, hold on. Backtrack. Yes. Here. Right. So A is one of those. And I think that's a counter interpreter. So we just pass it a counter interpreter. And then we pass it a what, which is that thing. But that thing really just threads state, I believe. Not the case? I think it is the case. So, but let's try and deduce its type based on this. Let's see if we're more or less aligned here. And right, so I think I need to go back to this for now. I think then that's, I think that's the right type, but then here that's not, because record. Where do you see a record? Got an F, the counter interface of that whole thing. So what's the deal? Oh, right. Okay. Yes. This. And now there's a problem still. Right, we don't want, we want an A, so we don't want hold on 1 second. We don't want we in fact passing render? Is it render we want here? And is it okay, see, if we pass render, then that's the A. And that's the A. So okay, go free. Take this A, and this A is this. Maybe we do it like so. And if that's the A, then we're saying that the F is counter interface. And therefore go-free FA is this monster go-free blah blah. And so counter interpreter being past render should have the type so since this is counter interpreter, that this is render. A tool that would unfold these things automatically like this would be super useful, wouldn't it? And so render is A and A, so we pass this into it. I mean, like such that counter interpreter render is this guy. Which is, oh, which misses, yeah, which misses a co-free. Okay, okay. Okay. So let's get back to it. So that blows up the type here, but I think it makes the type there work. And in that case, we don't need the what. And if inside our functor what we need instead of a decrement, a record, and so on, we need a cofree of blah. Then we need to make a cofree again in there. But maybe we can make it with this what possibly. There will need to be something like that, right? In fact, yeah, I'm not sure at this point. A counter interface that contains cofrees. So yeah, no, I think it will need to contain a cofree in here somehow, right? That would be one of the values, and that would be another one of the values. Not quite. Let's try and see the whole thing. Function count with cofree count. Okay. Yes, because you'd want this whole thing to be part of type. Yes. And then these things have another type from hell. Okay. It's a counter interface. Of goofy counter interface, of counter model, of the COT, store T. Yeah, because the truth is that I'm not even really. No, that I think it works. I'm just. Yeah, no, because I'm not even running store T yet. So I need to run store, don't I? Or run store, yeah, no, run store T. Okay, well, we'll come to that later. I think what this says is this needs to be the thing that passes state. There's the count, and it needs to pass the count to whatever is being passed to it. Could it just be another counter interpreter render? Maybe. Hold on. Run store T, takes a store T, and a tuple blah. and return the tuple blah. Okay. Hold on, I have no idea. Let's do this. Holy moly, these compiles! I have no idea. Okay. Probably defer. And if I defer, then I pass a something that takes the unit and returns a tuple of those things, I think. It goes a tiny bit faster or further, but it still breaks at construction, I suppose, here, because I should probably use defer co-free right there as well. Taking unit and returning a tuple of these things. And it's very ugly for now, but that's, if it works, it'll be pretty amazing. And that's the other part of the tuple, so it probably needs to be parenthesized properly. And it does compile. And it only does one run. Why would it? But it doesn't blow up anymore. But am I giving it any action? I'm not subscribing anymore. So can I do this? Well, first of all, I suppose let's try and put back directly a handler in the render function. And okay, it blows up the stack. It blows up the stack, but I'm pretty sure there should be a way to allow it to run. I wonder how. I wonder if it's because of this loop here. That is something where I should try and make this lazy. Basically defer this. Okay, and defer. Taking a unit to blah. Is it the type that's not good? L. Ah, right. Okay, yeah, I suppose. No, yeah, right. I don't want to defer it at this point. Do I? How does it work? Yeah, this is two lazies. This guy, and then in control, and then this data lazy, right? Right. And so ideally we'd force here something we had deferred. Oh, right. Right. Is that? Yes, and then you'd want this to be lazy, right? Creating a lazy value. Why wouldn't that work? Force takes a lazy A. Defer creates a lazy A. In our case, I want it to return this function, but explore, yeah, it should work. It's not obvious. The looping. If we loop with a counter, passing the init stuff. This is really run. Could not match type. What am I missing here? Loop takes a counter, which is a component counter. So this will defer, should be of type lazy of a component counter. And that's lazy from data.lazy. But apparently you're not happy with that. Okay, let's try and my viewers. Now you think that Go returns a lazy value, but I don't think it's supposed to. Yeah, I think it's supposed to return actually an effect string. Not sure I like that. That might be completely wrong. We want to explore. To take this crazy guy, which is a component counter to effect unit. Is that right? And then do we need effect unit here too? Still not. Oh, okay. And am I using the correct defer? Control lazy. I am not. That thing is. Oh wow, it just compiled. And I need to add my handler and see whether it spins forever very fast or it blows the stack again. Blows the stack. Okay, well, I remember that there's quite a lot of attention that needs to be paid to constructing infinite data types, possibly, and then to, in their execution, making sure that each value that you get is productive or is a thunk or something like that. It doesn't loop forever. But it could be that this approach, I mean, this is bad, right? If we can write it, but that in effect it blows up our program, then we're really not benefiting from what we want from functional programming languages. So let's write this down and call it a day. So we are doing this, but so in fact we have done that. And now we're trying to fix the stack overflow when handling directly. So yeah, it could be about this notion of handling directly. It could be that actually handling in particular in Explorer here, that this somehow needs to be, or it could be because of Runco. It could be that this guy needs to be deferred and forced elsewhere. And it could be also that this, like right now, I'm actually forcing a defer right immediately, but that doesn't sound right either. Could be that I need to defer here and maybe force in the log, something like that. And I might need to fmap around that. Yeah, so a few things to work out here. And then next to that, what else? I mean, this feels like progress. It's still very rough around the edges in a lot of places here. Yeah, what I would like to try then is to try and use the init setup. Yeah, set up a stateful subscription on init initial on component initialization, which might just be, well, yeah, I'm not sure whether it is this time about setting things up here. It is not as clear as I would like in my mind, but I think looking at it with fresh eyes on Thursday, in 2 days, will definitely help. What can we say we've achieved here as well? So we've refactored the store. We're not at the point where we can necessarily run that we can think of our interpreters as effectful yet. So we still need to do that afterwards, right? How does that affect our goal of effectful interpreters? And I think in the middle here, something we can write is that, I mean, yeah, we could lift. There's probably a lowering and lifting here that I'm not doing properly. Figure out how to lower Comonad in Comonad transformer stack so we can read about that. Because I think that's probably what I'm doing manually here, but also doing it specifically with that co-free with co-free actually probably takes a specific shape. And I suppose for that we could take a look at co-free T and the lower implementation for it. In the instances, lower is just head. Okay. So we need to figure out about that. And yeah, because it must be unwrapping just one of the containing layers, because co-free TFWA has W wrapping things. So you're getting the head is simply going to get us the inside of the component. So it makes sense. But we need to find out more about whether that's useful in our context or whether we actually need to lift somehow. because monad trans co3t is co3t prime map co. So maybe this is more like what we need. So lower would be for the comonad transformer, but there's a monad trans for co3tf. If f is plus, what is this? I'm not sure this is that's really interesting, but I'm a bit doubtful of that. Even this actually. All right, so this must be special cases. They're interesting, but they are not our co thing. We would want to have, if we use co3t. Oh, okay, yeah. Figure out if using co3t is needed, or if store t is fine. Okay, so we have a bunch of things to do next time. So thanks a lot for watching. I was Junchan, and we're still exploring comonads till the bitter end, and we'll do that again, hopefully with more interesting insights, and hopefully at some point starting to build stuff on top. Thanks for watching, and bye-bye.